Recording uh, and start the screen share. Okay, let me go to the. Okay, can you see my screen, my student?
Yes, sir.
Yes, sir.
Okay, so I'm muting all my students for the better audio quality, and also giving you the opportunity, if when you want, you can you know unmute yourself, no problem. If you have any questions, drop in the chat box. But definitely, first of all, drop your role in the chat box. That is the main important thing. Your role in the chat box. Okay, everyone, your role and batch also. Not only role and batch also. Everyone, drop your role in the chat box. Okay, so this is the attendance. So everyone, drop your role in the chat box. You don't need to write your name. It's not required. Just your batch and your role. That 29 batch, roll 10, or 30 batch, roll 12, something like that. Mm, okay. In the last class, if you do not, attend that class, it will be difficult for you to trace. But still, I will try my best to help as much as possible for you. So it was the Clipper circuit we are studying, the Clipper circuit. Okay. Uh,
Yes, sir.
the Clipper circuit we are studying. So we have shown 2 or 3 Clippers. If you do not do the class, please just check the video. It will be, full described video, so you can get it. Okay, but today we will see uh, my students. Yesterday, whatever we did, whatever we did those clippers, if you remember, are in series with output. If you see that, similarly, this diode, this diode is in series with the resistance. That's why these diodes or this type of clipper circuit is also known as series clipper. Okay, I didn't mention that because I don't want to, give you so many thoughts for getting you confused. But I'm telling you that if the diode is in series with the load, with the output, because it is the R is the output, then it is known as series clippers. Today we will see some of the parallel clippers also after 1 or 2 example of this. Okay, okay, let's start. If you see that, so this is the series clipper circuit and also biased clippers. Why? Because there is a DC supply available here. I discussed also unbiased and biased clippers, but this is biased because there is a DC supply available here. So what will be the first thing? The first thing will be you need to check the status of your diode. Okay, we need to check the status of the diode. This is the clipper circuit. This is the input voltage. If you are free, first I am describing you also first. This is the input voltage, the sinusoidal voltage, so which is has a positive cycle and also the negative cycle. Okay, so so what we will do, we will first of all we will analyze for the positive cycle, and then we analyze for the negative cycle. Okay, so let's go for the positive cycle first. uh, Watch my explanation properly. It will be very easy for you. So we will first of all we will analyze for the positive cycle. My student, um, you see that for the positive cycle, the input voltage will be like this. This will be plus and this will be minus. Okay, the input voltage will be like this, and we need to check what is the diode condition. Is it forward bias or reverse bias? We all know that this is N, the vertical line is N, and the the triangle is P. Okay, so you see that this plus is basically connected with this vertical or N, and this minus is connected with P. So basically, this is the configuration of reverse bias condition. I described several times, but still I am describing, this is for P for positive. So it should be positive for forward bias. But here P is connected with negative and N is connected with positive. So it is a reverse bias condition. Okay, my student, it is a reverse bias condition for this positive cycle. But interestingly, it can be applicable only when there is no DC supply. Okay, when there is no DC supply. So interestingly, if you check that for DC supply, this is minus connected with minus, and this is connected with plus. Because if I go, something like that, if I go in this round, so basically this plus is connected with this, and this minus is connected with this. So uh, N is connected with minus, and P is connected with plus. For this DC supply, this diode is forward biased. So here the dilemma and the contradictory conflict happens. Sir, this is forward biased, but for VI, this is reversed bias. So what will be the exact output, or what will be the exact scenario? My students, I told you that when the value is greater than there, that effect will be active. Suppose there are two parameters. One is now the VI, the input voltage, and also the DC voltage V. So when the VI will be greater than V, the effect will be for VI, and when the VI is less than V, the effect will be for V. If I allow you, I discuss in Bengali for one line. এখানে দুইটা ভোল্টেজ আছে, one is VI, another one is V. তো যখন যে ভোল্টেজটা বড়, তার ইফেক্ট তখন কাজ করবে, আর যখন যে ভোল্টেজটা ছোট সেই ইফেক্টে কাজ করবে না। যখন ভিআইটা বড়, তখন এই ভিআই এর জন্য এই ডায়োডটা হবে রিভার্স বায়াস, আর যখন ভি এর ভ্যালু বড়, এই ডিসি ভোল্টেজের ভ্যালুটা বড়, তখন এই ডায়োডটা হবে ফরওয়ার্ড বায়াস। সো get back to that. If we definitely, if you draw a line of DC voltage, so this is V, okay. Let me clear this drawing and make it a bigger one, so it will help you. Okay, now it will help you. You see that? Let me draw a line. So there are two intersection points. This is one and this is one. You see that? This is the V. So this portion, in this portion, VI, the input voltage is less than V, if you remember, or if you check. And also this portion, the input voltage is less than V. So in this portion, V is greater than, so the diode will be forward biased. And in this portion of this input, the VI is greater than V. The VI is greater than V. Okay. So for that, it will be reverse biased. Am I clear? So I think you clear that how the VI and the V will be greater than or less than. Let me go to the next, that how they solved. So basically, whatever I have told, they have done exact same things. That when the VI is less than V, the diode is forward biased. When VI is less than VI is greater than V, that means the value of VI is big, this portion, until this portion, the diode is reverse bias. So if we apply KVL here, in this loop, what will be there? The first sign of everything, starting from this one, this is the second sign, VI, this will be the second sign, minus V, and this will be the second sign, minus V naught. So if we apply this and make the KVL, that look what happens. That applying KVL, sir, it will be something like that. The output will be VI minus V. The output will be VI minus V. So for forward bias, we all know that what will be the forward bias. So for forward bias, you see that when the starting forward bias means, check my drawing here. So this is for positive cycle, okay, and this is V, my students. So this is the point and this is the point. So till this point and till this point, the till this 2 point, the diode is forward bias. The diode is forward biased. So this is the output equation, V not equals to Vi minus V. So from here, starting the input voltage is zero, Vi is zero. So when the Vi is zero, what will be the output? Just put the value Vi equals to zero, you will get that the V output will be minus V. V output will be minus V. And when this is the exact point where the Vi equals to V, in this point, in this point, you know, in this point, the Vi equals to V. So when the Vi equals to V, you see that the V output equals to zero, because if you replace the Vi using V, you get that V minus V equals to V not equals to zero. Okay, so this is for forward bias, minus V to zero, minus V to zero. And in reverse bias, when the in this portion, I'm talking about this portion, my student, this is where the Vi is greater than V, reverse bias. So reverse bias means there is no current flowing. So when the reverse bias, so output is zero. The reverse bias, there is no current flowing, so there will be output, the current will be zero, so the voltage will be also zero. So this is for the, you know, positive cycle. What we have discussed, this is all for the positive cycle. Let me go back one more time and tell. Let me go back one more time and tell. Uh, my student, you see that when it is forward biased, this is plus and this is minus, it will be just shorted, so the current will flowing, the current will flowing. When the current will flowing in this resistance, we will get the voltage. Okay, this is for the forward biased condition. But when this is, reverse bias, when this is reverse bias, this is plus, this is minus, this is reverse bias, at that time it will be just like open circuit. This diode will be open circuit, so there will be no current, there will be no current, I will be zero, I equals to zero, because there will be no current here. So when the I will be zero, there will be no current in this resistance, there will be no current in this resistance. And we all know that V equals to IR, the Ohm's law, V equals to IR, everyone, we all know that V equals to IR. So when there will be no current, whatever the value of your resistance, your voltage V output will be zero. So for reverse biased, output voltage VO equals to zero. And for forward biased, the output voltage we will get. Okay, we will get the output voltage. So this is something like that for the positive cycle. Now we will discuss in the negative cycle. Okay. Okay, let's discuss the negative cycle. So for negative cycle, now this will be minus and this will be plus. This will be minus and this will be plus. Okay, so if you see, sir, for negative cycle, uh, for this input voltage, this is plus and this is minus, and also for this DC voltage, this is plus, this is minus. So that means for negative cycle, both for both for input voltage and the DC voltage, the diode is forward biased. Okay, the diode is forward biased. So this is shorted line. So the current will flow in this direction. The current will flow in this direction. The current will flow. So what will be the output voltage? We need to consider. So what will be the output voltage? So at that time, we will just apply the KVL. If we apply the KVL, if we take the first sign, then it will be plus VI. Okay, plus VI. Then we take the first sign, it will be plus V. This first sign in the KVL, plus V. And then if we take the first sign, it will be plus V output. So everything is plus. So this will be our equals to 0. This is the KVL equation. So from here we want to know what is the output equation. So the V output equals to minus VI and minus V. So that is the output equation for V output. Okay. So this is the output equation for output voltage. So you see that this is the negative cycle. If this is the negative cycle, so negative cycle starts from the 0. So let's see what happens when the value is 0. So when the VI equals to 0, when the VI equals to 0, this V output equals to minus V. You see, the V output equals to minus V. And when the top value is Vm, the Vi equals to Vm, at that time, the output Vo equals to minus Vm, my students, minus Vm minus V. So that is the output value it will be for the negative cycle. So what I have written, it is also written in the next page. So let's go to the next page, which will give you much more clear idea. Okay, so it's same that they have taken the second sign, that's why the equation is like that. But you see that the equation is same, that V output equals to minus Vi minus V. So when the Vi equals to 0, the output equals to V output equals to minus V. When the Vi equals to Vm, the peak value, the output equals to minus Vm by V. If we take the common of minus, it will be Vm plus V. So this is our negative cycle. So so let's get back to the waveform. So whatever we have analyzed from here, we'll go back to the waveform. Okay, finally, you see that. Let me make it a lot much more bigger so you understand. Okay, my student. So whatever we have done in the calculation wise, now we go back to the finally waveform. So this is our positive cycle. So we'll first discuss the positive cycle. In the positive cycle, we told you that, sir, at some portion it is forward biased and in some portion it is negative reverse bias. You see that in the forward bias, it is something like this. This is the forward biased position. And here we discussed the equation was, if you remember, let me go back to the equation one more time and discuss here one more time. I'm discussing only one example today for your better understanding. You see that the equation is V output equals to plus Vi minus V, plus Vi minus V. Okay. So let me write the equation. That for the positive cycle, this is my student. This is for positive cycle. V equals to plus Vi minus V. So Vi minus V, Vi minus V. Okay. You see that this is the equation. So we need to express this positive cycle. So how many stages in this positive cycle? You said this is the V. So at the very beginning, the value of Vi equals to 0. You see that? The value of Vi equals to 0. and this point, this intersection point, the Vi equals to V. I'm drawing this here for your clear understanding one more time. Suppose this is positive cycle, my student. This is the V. And this is the V. So starting point, it will be Vi equals to 0. Here, this point, I'm making it this point. This point, my students, I'm using a different color. This point, you see that this Vi and also this V is same, exact same. So till this, you have the forward bias, and when you go this portion, this is the reversed bias portion. Okay, still this, but this portion, you see that this portion, the yellow one I'm drawing, this portion is the forward bias. So I'm using maximum tools for you understand. This is the forward biased portion, because in this portion the Vi is less than V. The Vi is less than V, and in this the blue portion, this is reverse bias, because here the Vi is greater than V. So we need to check this. So for forward bias, okay, so starting value Vi equals to 0. Vi equals to 0. If I replace this Vi value equals to 0, the output Vo will be minus V naught. Minus V naught, if you see. The output V naught will be minus V naught. So that's why I see that the starting point here, this is 0. The starting point is minus V naught here. Okay. Then this point, I'm talking about this point from 0 to Vi equals to V. If I replace this value, in this equation, then V minus V, the output Vo will be 0. The output Vo will be 0. So if you see that in this point also, this is the Vi equals to V point. So you see that this is the point here, the output is 0. The output is 0. So this is for positive cycle. And in the reverse cycle, or reversed bias, this portion, till this portion, this is the reverse biased. So there will be no current, I discussed. So the output will be 0. The output will be 0. Okay. The output will be totally 0. So here you see that I am talking about this portion. This is the reverse bias portion. So you see that this portion, the output is totally 0. You can see that the output is totally 0. And here on it is exact same like this one. Exact same like this one. So the middle one is the reverse bias, and the two side is the forward bias. So this is for the positive cycle, my student. I think you understand now. I'm again discussing one more time that this portion and this portion, these two portion are for forward biased, and the middle one is the reverse biased. This middle one is the reversed bias. So that's why there is 0. Okay. So for the negative cycle, now go back to the negative cycle. Suppose I'm drawing here the negative cycle one more time. Okay. For the negative cycle. So for the negative cycle, my student, the equation was, the output equation was V output equals to minus Vi minus V. Okay. So you see that from the negative cycle, the starting value is 0. This is the value 0, definitely here. This point is 0 in this. And the peak value is Vm. The peak value is Vm or minus Vm. Basically, this is in the negative cycle. So minus Vm, the peak value. So my student, if I replace the value 0, then the equation will be, the output will be minus V. The output will be minus V. So when the input is 0, when the input is 0, you get that when the input is 0, you see that this is the input is 0. When the input is 0, the output will be minus V. You see that the output will be minus V. So similarly, I drag a line here. You see that the output is in the, this is the minus V portion. You see that this is also marked as minus V. So similarly, this side will be also minus V. And when the peak value Vm, if I replace this value the Vm, so at that time it will be minus Vm plus V, sorry, minus Vm minus V. If I take common of minus, so at that time it will be Vm plus V, Vm plus V, okay, Vm plus V. So that's why you see that this is the peak value here. So in the peak value here, it is written as the minus Vm plus V. So that is the negative cycle waveform of this, So I think that we have discussed enough, and you just need to practice by yourself and see the video once or twice. But still, I am clearing everything, and I am sorry, I am going unmuting my students. If you have any questions, regarding this, you can ask me, my student. Everyone is unmuted. Just unmute. If you have any question, you can ask me, and
Yes,
if
sir.
you don't have, then I will move forward, my student. I think
Okay.
today we have discussed enough, because I have also shown these type of problems in the last class also, but still there are some new students. That's why I have discussed these small problems so deeply, step
Okay.
by step, using drawing, using equation several times. So I think that if you watch this video next time and practice by yourself, it will be easy for you. Am I
Okay.
right?
Yes, sir.
Uh, so I think I can move forward.
Exactly.
Okay. So my student, there are similar type of one more thing, one more example is here, and it is also solved by me. Here you can see that, and also drawing by me. It is done. So if you just follow the same procedure and check this process, you can also solve here. And so I have given this lecture. I have probably solved 4 or 5 problems, something like that, in these biased clippers. And this is the series clipper, my student. So you just check this video lecture, the previous class lecture, and also this this slide, or what kind of, this PDF to study. And you have also your book in your hand, so you can study from your side. So now I will go back to the today's new topic. Not new, almost same, just in different. Yesterday or today's early part, we discussed the clippers, that is series clipper. Today we will see. Today we will see the parallel clippers. How you check? So what are the parallel clippers? What are the series clippers? You see that this diode is parallel with the output. That's why it is known as parallel clippers. When the diode is in series, you see that, if you remember in the earlier example, the diode is here, and which is in series with the output. That's why it is series clippers. Now the diode is in parallel. The diode is parallel with the You see that this is the diode and this is the output section. So the output is now across the diode and both are in the parallel. So that's why it is known as parallel clippers. I think everything is clear for you. So my student, uh, my my student, if I this is very simple type of parallel clippers, and it is also unbiased because there is no DC supply here. Okay, and so this is the input voltage. If you see, this is the input voltage, and this is the output voltage across the diode. If you, the first thing I always tell you that, my students, you check the status. You check the status of your diode, and this is the input voltage, the square wave, the which has the positive cycle and the negative cycle, the square wave. So we will discuss one by one. First of all, positive cycle, then negative cycle. So for positive cycle, this is plus, this is minus. So you see that this, if this is plus, this P will be plus and the N will be minus. So this is also forward biased. This is forward biased, my student. Okay, so if it is forward biased, then the current will flow. The current will flow. So when the diode is forward biased, my student, when the diode is forward biased, that means this, if you can replace this diode, this shorted line, replace this diode, this shorted line. And we know that when it is shorted line, there is no voltage drop. There is no voltage drop. So when there is no voltage drop, when this is shorted line, something like that, when there is no voltage drop, so the output is across, you can see that the voltage output is across this diode. So but the diode has no voltage drop because it is shorted line, there is no resistance in the diode. So that's why the whole input voltage will be dropped here, because in the KVL we know that the summation of voltage drop equals to input voltage. So in the output voltage, as there is no drop in the diode and output is also across the diode, so the output always will be zero in the positive cycle. So that's why you see that this is the positive cycle. You see that there is no output, the output is zero. Okay, uh, it's very interesting. Similarly, if we discuss for the negative cycle now, this is the negative cycle. My student, in the negative cycle, we know that now the sign will change. This is minus, this is plus, this is minus, this is plus. So you see that this is now, this will be minus, this will be plus. This, the diode is now the reverse bias. So the diode is reverse bias. So there will be no current. Now there will be no current. My student, there will be no current. There will be no current flowing in this circuit. So if there is no current flowing, so what will be the effect? You see that now, if there is no current, so there will be no, it will be, as it is reverse bias, so it will be open circuit, something like that. It will be open circuit. So there will be no branch. So as there is no current, so the voltage drop in this resistance will be zero. So you see that the whole input voltage now will be applied in the output. So whatever the input voltage, that will get in the output terminal, because there is no voltage drop in this resistance. Why? Because there is no current here. So at that time it will be Vi equals to V output. So the output will follow the input. So mark this line very carefully. You can write this line. So when the diode is open circuit or the diode is reverse bias, the output will follow the input every time in the parallel clippers. When the diode is reverse biased, and the diode is open circuited, the output will follow the input, because there is no current here. So whatever the input we are giving, we are getting in the output. There is no voltage drop in the resistance anywhere because there is no current flow, my student. So you see that the exact same flow in the output. So the output is following the input. You can see here the output is following in the input. If we check one more, you know, you see that in this sawtooth waveform, you can also see that in the forward bias there is no voltage, but in the reverse bias, when the output is, you know, following the input exact. So always remember that in the reverse bias, when the diode is reverse bias and open circuited, at that time the output will follow the input. That means the input equals to output. So this is, you know, this will be always true, true line for your rest of the mathematics also. So always you can take this note also when the output is the diode is, you know, open circuited or the diode is reverse bias. At that time, the output will follow the input. Basically, the input equals to the output. So I think that you are clear here, very much clear. So let's go back to the next. Uh, let's see what is given in next. Uh, so there is one more, my student. Uh, okay, you can also see here that now the diode is parallel in output, parallel as output. That's why it is known as parallel clippers, my student. It is known as parallel clippers. This is the input given here. A sinusoidal wave is given here. Okay. So in the positive cycle, this is plus and this is minus in the positive cycle. So this will be plus and this will be minus. We know from this configuration, this is reversed bias. So when it is reversed bias, my student, this terminal will look like this, the open circuit terminal. This terminal will look like this open circuit. Open circuit, that means diode is reversed bias. I just told you that the input will be equals to the output. The output will follow the input. Same. I just told you that when this will be reversed bias and they'll be open circuited, at that time, this input will be exact same the output. So that's why you see that this is the input. You can see the exact same replica in the output. Am I clear? So if you remember this line, it will be very helpful for your rest of the understanding. Okay, my student. Uh, this is for positive cycle, and what about the negative cycle? If you see that, so this is minus, this is plus, and at that time this will be plus and this will be minus. So basically the diode will be forward biased. So the diode will be forward biased, my student. When it is forward biased, it is just like a shorted line. When it is shorted line, as it is an ideal diode, the voltage drop is zero. So the V output will be also zero because the output is across the diode. So you see that in the negative cycle, there is no voltage in the output. So I think you were clear in this type of a parallel clippers. So today, um, uh, uh, okay, I am going to my students one more time, and can I continue, my student?
Yes, sir.
Can I continue, my student?
Yes, sir, no problem.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. Thank you so much. Thank you so much for allowing. I think you are understanding, my student.
Yes, yes, sir. Probably.
Yes, sir.
Are you enjoying? Is
You
there
got
any
it clearly.
Yes, sir. Yeah.
is there any doubt on your
One more,
mind?
sir.
Thank you so much. If you have any
One more,
doubt,
sir.
please ask me. Please ask me. I will be happy to answer you. Okay, I'll be more than happy to answer you, all of you.
Okay, sir.
Thank you so much. Okay, so you see that these are the clippers, the parallel clippers, my student, but it is unbiased because there is no DC supply. So now we will check one or two just like this, my students. Don't get panicked. Just like this. It is very easy, and just without any calculation, you can just draw. Uh, let me help you. You see that, sir? Now this is a DC supply is added here. That's why it is known as biased clippers. Biased clippers. That's why. Okay, it is known as biased. Sorry, my bad writing. This is known as biased clippers, and you see that the diode is across the parallel of the output. That's why it is known as parallel biased clippers. Okay, parallel biased clippers. Let me tell you that this is the input voltage, the sinusoidal voltage, and we will discuss again. I am telling you that you have to discuss the positive cycle and the negative cycle separately, so that will give you the liberty, that will help you to understand easily. So for positive cycle, you see that, my student, and so for positive cycle, let me discuss the positive cycle. So positive cycle, this vi is, this is plus and this is minus. Okay, so this is plus, this is minus. So the first thing we need to check the status of diode. Okay, so you see that the status of diode, this is positive, this is negative. Okay, this is positive, this is negative, my student. So this is positive, this is negative, clear. So at that time, this will be shorted line. Okay, this will be shorted line. So when it is forward biased, my student, when it is forward biased, just understand, when it is forward biased, so this is shorted line. So we can replace this diode, just the shorted line. So now, if we calculate the output, we know that the output is across this line. If we calculate the output, you see that only this voltage, this DC voltage will be there. Okay, so we get that because this branch is in a parallel with this output branch, so that's why it is shorted line. So this is the 0 voltage, so that's why we get only output will be equals to just the V voltage. Okay, so when it is forward bias, the output V output will be, my student, V output will be V. Okay, but there is a DC supply available here. Okay, so you see that for the DC supply, this will be plus, this will be minus. So you can predict that this is the reverse bias condition. So for DC bias, for DC supply, this is reverse bias condition. So when it is reverse bias, my student, when it is reverse bias, this diode will be something like that, the open circuit. Now the branch will be something like that. Okay, when it is reverse bias, the branch will be something like that. So that means it will be reverse by open circuited. So when the branch is open, there will be no current flow. There will be no current. I will be zero. The I will be zero. And I told you at the very beginning of this parallel circuit, when this is the open circuit or the diode is parallel, sorry, the diode is open or the reverse bias, the VI equals to V. I told you the VI equals to V output. So the whatever the input we have will be same as the output. I'm telling you, it is third time that when the diode is reverse bias and it is open circuit, there will be no current flow. So that's why the output will follow the input. At that time, the VI will be V output. The input voltage equals to output voltage. So this is forward condition. Sorry, this is reverse condition. And the forward condition we already discussed. So the next thing is that, so when it is forward bias, when it is reverse bias, my student, this DC supply is making this diode reverse biased, and this input voltage, this input AC voltage is making this diode forward biased. So sir, when it will be forward, when it will be reverse, I told you that when the VI value will be bigger one, it will be forward biased. When the value of V is bigger one, it will be a reverse bias. So I'm drawing the positive cycle much more bigger way, so you can understand. So this is the positive cycle. Okay, this is the input voltage VI, and DC voltage, I'm drawing the DC line here. This is the V. You see that I'm using a different color for your better understanding. You see that at the very beginning, the VI equals to 0. So it starts to rise, it starts to rise. So till here, both the voltage are equal. When it cross this, point, the VI is greater than V. So that's why till this type, the V is greater than. But also this similar, this is the same. Till this two portion, the V is bigger. The V is bigger. But when the value crosses this line, so till this, the upper portion, the VI is bigger. So that's why in this two small portion, it will be forward biased, sorry, reverse bias, and this portion, it will be forward biased. Okay, so you just clear everything. So this is the input. Okay, this is the input. So what will be the output? Let's check. So what can be the output, my students? If I extend this line here, okay, and suppose this is the V line, this is the V line. So you make a line here, you make this line here, and you make line this here. So this is the V line here. So I told you that this portion is forward biased and this portion is forward biased. Sorry, I'm again saying it is reverse bias. Reverse bias, and when it is reverse bias, the output will follow the input. The output will follow the input. So the input is something like this. The input is something like this. The output will also the same, something like this. Okay. And when it is forward biased, we discussed this is just a shorted line. At that time, we get the output as V. So same, we get the output as V. So this is for the positive cycle. This is for the positive cycle, my student. I think you understand. I have used different colors for me to understand. When it is reverse bias, it will follow the input. When it is positive bias or forward bias, we just calculate the value that it is plus B. So this is for the positive cycle. So what about negative cycle? Negative cycle. The negative cycle, this is minus, this is plus. And you see that for the negative cycle, this is plus, this is minus, and also for this DC voltage, this is plus, this is minus. So both the value, my students, are making this diode reverse bias, both the input voltage and also for the DC voltage. So when it is reverse bias, I told you that it will be open circuited. It will be open circuited. When it is open circuited, I told you that the input voltage will be equal to the output voltage. I am telling this for the fourth time. When it is open circuited, this input voltage will be equal to the output voltage. So at that time, this is the input. The output will be also same as this input. The output will be also same as the input. So there will be no change in the output waveform. So we discussed with using only the diagram. So it is, given here. The explanation I am given here, and if you just see this diagram here, in the positive cycle, whatever I just draw here, this is the positive cycle output, and the negative cycle, it is the exact same in the negative cycle. Okay, my student. So I think you get this type of example, and one more example I have solved here. So you will practice after this class by yourself. You will practice, and just giving you a clue, for this. And for the positive cycle, this is plus, this is minus. Okay, and for the negative cycle, it will be, minus, it will be plus. So you have to calculate according to that. So in the next class, we'll start our proceedings from there on. So till then, I think we have done today is enough. So I don't want to overload this. So I'm clearing this everything. So you practice this one by yourself according to the last example. In the next class, we'll start. Now you can ask me any questions if you have anything in your mind.
Okay.
My students, if you have any questions in your mind, you can ask. My students.
Sir, I am Amir.
Yes,
I
sure.
don't have a question.
But
Sir, how about all the time you calculate voltage like KVL, something like that?
yes,
So in this diode, maybe it's ideal diode, right?
yes, yes.
So
What about silicon diode?
silicon diode, yeah, the
Yeah, yeah.
situation would be different, right?
No, I'm throwing you this question that
Yes,
what about what will happen in the silicon diode? You just
exactly.
in the after this class, you think you just replace this ideal diode in silicon diode, and at that time the value will be V, output will be not zero, it will be 0.7. Okay, we all know that 0.7 voltage,
Exactly, yeah.
isn't it?
Yes, yes, sir. Yes,
So
sir.
you just practice by
Yes,
them.
sir.
You just
It's right.
practice by 0.7. In the next class, I will show one or two
Mm.
using practical diode also. Okay. So today I will not discuss, because it will give you
Okay, sir.
confusion, and still you need to think by yourself. But in the next class, I promise you, I will show one or two examples in the using practical diode also.
Okay.
Okay. Okay.
Okay, sir. Thank
So
you.
is there any question, my students? Okay, everybody, I think everybody have given the role in the chat box, I believe.
Yes, sir.
Still, if you do not, please give your role in the chat box. And my students, the exam is very near, so the next class will be very important. So don't miss that class. And what I'm trying to say that I will also help you that how to guide. So please tell all students, your friends, everyone, that Mamun sir has told to come there, because the next class will be very important, because after that we don't have the any class,
End
scheduled
of
class for
time.
exam. So tell all students, inform everyone that Mamun sir has told to come, and we will discuss from there on also. And after this class, I will upload the video lecture and also share the class lecture with all of you. And I'm telling you, Amir or some other students, please upload this in
Okay.
your group. Upload this in your group. Share with all students. That's
Okay,
all.
sir.
Everyone, stay safe, stay home. That's it for today from my side. Okay.